each problem. What did you write? Read from your paper. Not from the board. Read from your paper. Letter A on the front.
The exponents equal to 10.
The exponents equal to 10. That's kind of the answer to letter C. What pattern do you notice about the exponents? Who has a different answer about what you notice about the answers? What do you notice about the answers? Andrea?
They're all the same.
They are all the same. All the answers are 1024. All right, letter B. What did you notice about the base? The base of each exponential expression. Emmanuel, what did you put for letter B? They're all the same. And what's the base? 2. So Jasmine already gave us our answer for letter C. The exponents all add to 10. If you look at the exponents, 2 plus 8 is 10. 3 plus 7 is 10. 4 plus 6 is 10. 5 plus 5 is 10. Did everybody notice that?
Yeah.
Y'all all notice that? Okay, let's go to the next problem, number 2. All right, they wanted you to write it in expanded form. Number 1 and number 2 were both activities on you trying to discover the multiplication rule for exponents. So when I do this, when I expand the 3 twice, and I expand the 3 4 times, and I rewrite it, it's 3 to the 6th. It's so much easier to do 3 to the 6th power in our calculator versus doing 3 times 3 times 3 times 3 times 3 over and over and over again. So on your homework, you should have got 3 to the 6th, 2 to the 13th, 7 to the 8th, 12 to the 5th, x to the 5th. And on this last one with the variable, that's actually the rule. What am I doing to A and B? I'm adding them, A plus B. Give yourself a pat on the back if you got the majority of your table correct. Pretty good, pretty good. All right, letter A. What does the exponent mean in each expression? Matthew, what does the exponent mean? What did you write for letter A? Perfect. How many times you have to multiply? The exponent represents how many multiples of the base are in the expression. That's another way of saying it. How many times you multiply the base. Letter B. Anasha. Write a conjecture or a rule explaining the process of multiplying same bases raised to a power. What did you write?
You write out all the bases. You write the bases however many times the exponent is, and then you just basically add the exponents together.
Basically, you add the exponents together if the base is the what?
If the base is the same.
If the base is the same. When you multiply numbers that are the same base raised to powers, you keep the base and add the exponents. So this activity should have led you to understand why the rule is the rule that it is. The first one shows you that no matter what the exponents are, if they add up to the same thing, you're going to get the same result. This one shows you the same thing. All right, let's look at number 3. This one is talking about the division rule. Who remembers, say it if you know it, what this line is called?
Vinculum.
Vinculum. Very good. I've heard a lot of voices. All right, so they wanted you to do the expanded form, so you should have had 3 written 4 times divided by 3 written twice. If I am dividing and I know I can eliminate that and I'm left with how many 3s?
2.
2 3s, and I rewrite that, you should have got 3 squared. The same thing with the second one. If I have 7 2s on the top, 6 2s on the bottom,
It's just 2.
you're only left with one of them, so the exponent is going to be 1. 8 7s on the top, 3 on the bottom. How many 7s are left? 6 and 2. How many 12s are left?
4.
4. And this is my rule. If I have the same base, I'm going to do A minus B. All right, letter A. What does the exponent mean in each expression? Javier, what did you write for your answer for letter A? The number multiplied by itself. Yeah, the exponent represents how many sets of the base are in the expression. So the number that you mean is the base. Okay. B, write a rule. What's my rule for dividing the numbers? Sarah. What is my rule? What you write?
So you can just choose some digits and I think they're subtracting the top and the bottom.
Oh, I like that. She said treat the division sign like it's a subtraction sign and you subtract the bottom from the top. Perfect. All right. You picked up a handout yesterday called Extending the Laws of Exponents. So take that out. Hold it up when you have it so I know you're ready. Extending the Laws of Exponents. I got one table, 2 people on one table. Hold it up, hold it up. The back table's ready. This table's ready. Come on, San Juan. Come on, Yadiseli. It looks like this. With a bubble on it. All right, let's go. Let's go. Good. All right, combining the laws of exponents. So far, everything that we've learned, your proof book, all the activities we've done, you've only done one law at a time. You did power to power by itself. You did multiply by itself. You did divide by itself. Negative exponents by itself. Now we're going to combine those laws. It's a little more tricky, but if you know the laws, I need you to put your head up, Anasha, please. If you know the laws, you should do all right. All right? So what I'm going to do all of number 1, and then you're going to do 2, 3, 4, and 5. That's your classwork. Once you finish, then you can play the games. All right, so let's look at these bullets up here. Somebody read the first bullet for me. Popcorn out.
Make sure our numbers are
Exponential form if they do not have an exponent, put a 1.
If they do not have an exponent, put a 1. That's crucial because a lot of times one of the biggest mistakes I see is if you don't put the 1, you forget to do the math with those exponents. Multiply, subtract, add them, whatever you're supposed to do. All right, so here's my first rule. I'm multiplying A times B. Is that the same base or different bases? Different. The bases are different. But what I have to remember is I have to raise A to the X power and B to the X power before I multiply them. If A and B are coefficients, I just multiply those numbers. So I get A to the X times B to the X. You don't add those X's because the bases are not the same. You just leave it like that. Now my next one is I have exponents inside the parentheses. Now I'm including the power to power rule. Who remembers that rule? Raise your hand. Matthew, what do I do with my exponents if it's power to power? Multiply them. Very good. So I have to multiply X and Y. I have to multiply X and Y for B. And that's what I get. The third one, now I'm dividing and I'm still raising it, the whole thing to a power of X. That's going to give me A to the X, B to the X. These bases are different, so I do not have to do anything with those X's. The last one, kind of like this one, but I'm dividing. I have an exponent within the parentheses. So just like Matthew just told us, power to power, I have to multiply. Multiply this exponent times what it's being raised to. Y'all ready to do something? Yeah. It's fun. I love it. All right. 2 times 3 squared. The whole thing is being squared, so I can either use PEMDAS, so there's 2 ways. What's 2 times 3?
6.
6. So here's one way. I can do 6 squared and get Say it if you know it. 36. But if I use this rule, I would do 2 squared times 3 squared. What's 2 squared? Say it if you know it. 4. Times 3 squared? 9. And what do I get? 36. So I get the same thing. All right, now letter B, I have variables now, so I can't do what I did here. Now I got power to power. 2, what am I going to do with that 2 and that 3?
6. I mean, multiply.
Multiply. You already got it in your head. 2 times 3 gives me x to the 6th. And then I'm going to do 5 times what?
3.
5 times 3, and what do I get? 15. Once you get your answer, put a box around it. X to the 6th, y to the 15th. Whenever you have variables, you do not have to separate them. You can just put them side by side, so I don't have to leave the dot. All right, let's look at C. Now we have coefficients and variables. Do I need to raise that -4 to a power of 3?
No. I mean, yes, you do.
I do. Everything in here has to be raised to a power of 3. This is where we start making mistakes. Everybody does pretty good on A and B. But when we get here, people remember the rule for the exponents, but they forget to raise the -4 to the power of 3 and the 3 to a power of 3. Get your calculators out. This is where you use your calculators. Everybody get your calculator. Who can explain how to use exponents on the calculator? How am I going to show -4 to the power of 3?
Me.
Say one.
You put the little caret, and then you put 2.
Put 2 or 3?
Means
Now,
6.
let's use our little note up here. 4 is being raised to the first power. That 2 doesn't go with that -4.
Oh, yeah.
And the 3 is also being raised to the first power. So if we look at it like that, it's like 1 times 3. So -4 is only being raised to the third power. Somebody type it in and tell me, what is -4 to the third power? -64. Who can explain why this is negative and not positive? Somebody different between Matthew and Jose. Why is it negative, Andrea? No. Adriana. My bad.
Because you multiply negative by negative, and you multiply that by another negative.
So a negative times a negative is a
Positive.
positive. Very good. A negative times a negative is a positive. So -4 times -4 is positive 16. Positive 16 times -4 is -64. All right, now let's do my exponent. 2 times 3. What's 2 times 3? 6. Notice I'm drawing my arrow. I'm not doing that extra step that I did here. Times 3 to the third power is what? Oh, who said 9? That is our rookie mistake. When you're dealing with exponents, it's so easy to say, I want to multiply the base times the exponent, and then you get 9. But that's a rookie mistake. What are you supposed to do with that base? Matthew?
Write it out
3 times. So what's 3 times 3 times 3? 27. If you don't know it, use a calculator. But you should know that one. 27, and then I'm going to do 3 times 3 for my y. And what am I going to get? 3 times 3. Now I'm going to multiply the 3's. 3 times 3?
9.
9. Am I finished with this problem?
No. Yes, you are, because they're different base. No. Variable? No? I don't know.
All right. Who says I'm finished with it? Okay. Elmer, explain why I'm finished with it.
They have different bases, so
That's what I said.
you can't put them together anymore.
Who says I'm not finished with it?
No.
Emmanuel.
Do you have to put the exponent, like the larger exponent first?
I know what y'all are doing. Y'all are thinking this is addition of polynomials. Y'all are thinking about what we talked about yesterday.
Oh, you're not finished.
Why am I not finished, Jose?
You multiply both of them.
Yes, that's right. You multiply the 64 and the 27. It's multiplication.
Yeah.
So do it. Somebody do it in your calculator. Now you would have been right, Elmer, if it was addition. If I was adding those, I would be finished because I can't combine unlike terms. But when you are multiplying or dividing, you can work with those coefficients. Yes. What is it?
Negative 1,728
Oh.
x 365y.